Okay, let's take a look here. So 4.1 talks about the rules of exponents. And the first rule we have is something called the product rule. And it says to multiply two exponential expressions that have the same base, keep the base and add the exponents. So I want you to notice what we have here. These two numbers are going to be the same. The exponents are probably going to be different, but the base numbers will be the same. When the base numbers are the same, all we need to do with the exponents is add them together. So if I take a look at the first problem, remember the base number is going to stay the same. The base number is going to stay 3. What we're going to do is with those exponents, we are simply going to add them together. So 2 plus 3 would give me 5. Okay. Let's do the same thing here. Remember, our base numbers are going to stay the same. That's going to stay in 8. 9 plus 12 should give me a total of 21. All right, let's try the same thing when we have variables for our bases. So now my base is going to stay as the letter A. We have 8, we have 12, we have a total of 20. My base will stay as an X. 4 plus 8 will give me 12. My base will stay as a W. Now I want you to pay attention to this one here. So this is an 18. Even though I don't see it, there is one W right there. So 18 plus 1 more gives me a total of 19, okay? Oh, let me pause that real quick because we're missing something here. Okay, so let's try the next problem here. And let's make sure everything is up and running. Yes, it is. Okay, so look at the next problem here. It says we're going to multiply 6x squared times a negative 9x to the third. Okay, so the first thing is we're going to multiply 6 times a negative 9. That'll give us a negative 54. Now again, with our exponents, because they're both x's, we're just going to add them together. So we end up with negative 54x to the fifth. I'm going to do the same thing here for the next one. So 2 times 9 will give me 18. Now let's go in pieces. So if I look at my x's, remember, even though I don't see it, there's 1 there. There's 2 there. Now we have a total of 3. And then when we look at our y's, we have 3 here and 5. We have a total of 8. Okay. We can do the same thing with the next one. So negative 3 and 7 is a negative 21. There's 2 a's right here. Even though I don't see it, there's 1 right there. It gives me a total of 3. There's 1 b here, 4 b's there. There's a total of 5, right? So for the next problem we have here, remember we're going to multiply fractions. Remember how we multiply fractions? We just go straight across. So 2 times 1 is 2. 5 times 3 is 15. Okay. My x's, there's 1 right there. There's 2. There's a total of 3. Our y's, there's 3 here and 2 there. There's a total of 5. Okay. So for my next problem here, I'm going to grab my calculator, so that we can multiply 2.3 times 3.5. It will make it negative. Okay, hit equals. So negative 8.05. Negative 8.05. Okay. I only have one W, so I'm only going to write that one W down. We have 4 x's right here and 1 right there. We have a total of 5 x's. And we only have those y's, so that would be y to the 4th, right? And so the next one here, I want you to notice we have 8a times 2a to the third b times 0. Remember, anytime we multiply by 0, the answer is just 0, okay? So let me go to my next page. Okay, so we have something here called the quotient rule. And the quotient rule is given to us in a couple of different pieces, okay? So what I want you to notice here, it says if we're dividing x to the a over x to the b, we're going to use x to the power a minus b if the larger exponent is in the numerator. So I want you to notice here, the larger exponent is on the top. All we're going to do, my friends, we're going to subtract. 5 minus 3 is going to give us x squared, okay? So when the bigger exponent is on the top, we're going to subtract the top one minus the bottom one, okay? So look here, 16 minus 7, y to the 9th. Okay. Now, there's a second quotient rule. It says, well, what happens if the bigger exponent is on the bottom? Well, if the bigger exponent is on the bottom, we're going to write a 1 on the top, and then we're going to subtract, but we're going to subtract the bottom one minus the top. So 9 minus 7 would give me 2, right? Okay, so before I go on, I kind of want to explain why do these rules work the way they work. Okay, so let's go back and do both of them. So x to the 5th, I want you to think about what that means. There's 1, there's 2, there's 3, there's 4, there's 5 of them, right? X to the 3rd means there's 1, there's 2, there's 3 of them, right? So if I were to come back here and say, oh look, this will cancel, those will cancel, those will cancel. How many x's are we left with? We're left with 2. They're on the top part, and that's why it stayed sort of on the top, right? I can do sort of the same thing here for this one here, okay? B to the 7th, guys, I'm going to write 1, 2, 3, 4, 5, 6, 7, right? Over B to the 9th, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then we can sort of play the same game. So look, those will cancel. I'm going to keep doing this. And if you notice, all the B's on the top are canceled, but we still have 2 and they're on the bottom. So they're left on the bottom. We're always left with a 1 on the top, and that's how we get our answer, okay? That's why the rule works the way it works, all right? So let's keep doing that. Remember, I'm going to write a 1. I'm going to subtract the bottom minus the top. That should give me x to the 4th. Guys, I want you to notice I'm still writing my x, okay? So it's not 1 over 4. It's 1 over x to the 4th, right? Let's do the same thing here. Okay, so first off, let's reduce 5 and 25. 5 goes into 5 once, into 25 5 times, okay? We have more x's on the bottom, and there's 2 more on the bottom. So I'll end up with 1 over 5x squared, right? Okay, let's try the next page. Alrighty. So I'm going to do the same thing here. Alright, 4 goes into negative 12, negative 3 times, okay? Let's see, I have more y's on the bottom than I do on the top, so we're left with a y to the 5th. Guys, I can just write my answer like this because there's nothing really left on the bottom, right? Let's try the next one. All right, so first off, I want you to notice a negative divided by a negative is going to be a positive, right? So I'm not going to even worry about writing a negative sign, but we can divide both those numbers by 8. So 8 goes into 16 twice, and 8 goes into 24 3 times. We have more x's on the bottom. How many more? Just 1. Okay. Let's take a look. So there's nothing for me to do, or nothing for me to reduce with that 5 with, so that 5 is going to stay there. Where do we have more a's? Well, we have more a's on the top, and there's 2 more on the top. Where do we have more b's? Well, we have more b's on the bottom, and there's 4 more on the bottom, right? Okay. Let's try this next one here. Let me grab my pen again. Okay, so 3 and 12, we can divide them both by 3. That'll give me a negative 1. That'll give me a 4. Okay, looks like we have more x's on the bottom. Looks like there's 4 of them. Okay. And it looks like we have more y's on the bottom, and we have 3 of them. Okay. All right. And there is a third part of the quotient rule. It says, what happens if the exponents are exactly the same? Well, if the exponents are exactly the same, guys, we end up with something called x to the power 0, which is equal to 1. Or we can think about it as they're simply going to cancel out. So look, 5 and 10, I can reduce them both by 5. That goes in once. Excuse me, that goes in twice. The b's will cancel because there's exactly 2 on the top and 2 on the bottom. And we do have more c's on the bottom, and we have 2 of them. Okay. Let's try the next one here. So let's see, 18 and 24. We can divide them both by 6. So 6 goes into 18 3 times. 6 goes into 24 4 times. We have more a's on the top. We only got 1 more. The number of b's is exactly the same, so they're going to cancel out. C to the power 0, guys, any of the power 0 is going to be equal to 1, so I don't even need to worry about writing the number 1 because it's simply the number 1. Okay. All right. So the next exponent rule talks about raising a power to a power. Okay, so when I'm going to raise a power to a power, what we're going to do is we're going to multiply our exponents. So 5 times 8 will give me 40. Okay. Here, I'm going to think of the exponent on my a on the inside as a 1, and we're going to multiply them by the number that's on the outside. So 1 times 4 is 4, and 3 times 4 is 12. Okay. Guys, I'm going to do the same thing here. I'm going to think of that power on my c as a 1, and I'm going to multiply each of those exponents by 3. So that'll give me 3. 2 times 3 will give me 6. 3 times 3 will give me 9. Now I want you to notice what we have here. We have 3 and we're raising it to the third power. That means 3 times 3 times 3. So that's 9 times 3. That is a 27, okay? So my number is still going to be raised to that power out there, okay? Alrighty. Let's try the next part here. Remember, we're multiplying our exponents. So 3 times 5 is 15. 2 times 5 is 10. Okay. Let's do the same thing here. 5 times 4 is 20. Now we have the number negative 2. 4 times, guys. Okay. So if I do that, that's going to give me 4. If I do that, that's going to give me 4. And 4 times 4 is simply 16, right? Okay. Let's try the same thing here. Okay, so remember my exponent on the x is a 1. So let me multiply. That's going to give me p to the power 25, x to the power 5. Now I have 6 to the 5th power, okay? So guys, I'm going to use my calculator for this one, right? 6 to the 5th power. So let me grab my calculator right here. Clear that out. 6 times, that's 2, 3, 4, 5, and then hit equals. So 7,776, 7776, okay? And let's take a look here at the next one. All right, so remember 5 squared. 5 squared is 25. X to the second power, because that number there is a 1. Y, 2 times 2 is going to give me 4. 7 squared, 7 times 7 is 49, right? All right, so that right there is 4.1.